Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Wintelect. Today we're going to be taking a look at the Cassandra API for Cosmos DB. Hi guys, today we're going to be looking at the Cassandra API on Cosmos DB. I wanted to look at this one because it's one of the more uncommon use cases for Cosmos DB, but it is one that I think that can be used in a lot of different kinds of applications if it meets the criterion for which it's designed. So let's go talk about that, and then we'll do a demo on how it works and when you might want to use it. So I want to talk about Cassandra just for a minute because Cassandra itself is what Cosmos DB is based on. It does a protocol implementation of Cassandra. I want to talk about Cassandra in general and then go over to the Cosmos DB API to show you how it works. So understanding what Cassandra is designed to do will help you decide whether or not you need to use Cosmos DB to do that with Cassandra. So what Cassandra fundamentally is a database like everything in Cosmos DB, but it's an open source distributed wide column database. Now we already looked at wide column databases when we talked about Table API. Cassandra is just another implementation of something that's kind of similar to that. But what Cassandra is really trying to do is provide a database platform that you can install on commodity hardware, such as virtual machines or bare metal, and create a cluster that can scale widely so that we can have a database that does something that's similar to what we expect from RDBMSs, but apply that to large amounts of data. So fundamentally, Cassandra is really trying to get at a database platform for big data. And to do that, it makes some assumptions and paradigm assumptions that need to be understood so that you can make the appropriate decision whether or not to use Cassandra. And the paradigms it adopts are going to be very much conducive to big data workloads, but not conducive to something like an application per se. It can be used for applications. Cassandra does support that. But the ideas that it's using are more conducive to something that's going to scale widely so that we can have a database that has high concurrency and lots of data and high availability rather than something that's going to provide strong consistency. And we'll talk about how it does that in just a second, but that's ultimately what Cassandra is aiming for. So to do that, it adopts eventual consistency, asynchronous masterless replication, and provides no single point of failure in the database. And these kinds of features are really what make Cassandra an ideal tool for a large database platform that's going to be useful for big data, but not something that's going to be useful for something that's going to be more traditional in its approach, like an application that needs strong consistency or normalization or whatever it might be. So when we're talking about a distributed database, what we're talking about is a database that's distributed across multiple nodes. What we have is a bunch of VMs or physical machines that are running Cassandra on them, and they all function together to create a single database. So what that allows us to do is write to any one of these given nodes, and the data gets replicated to every other node in the database. And that replication happens through that asynchronous mechanism that it uses to replicate data. So if I write to this particular node right here, then the replication process then will asynchronously write to this node that given write, and this node to that given write, this node to this given write. And so eventually all that write gets applied to all of the nodes, and that allows for clients to be able to read from any of those nodes once that write has been written. Now, with strong consistency, what that means is what we do first is write it to a node, and then as the transaction occurs, it writes it to all the other nodes, and the transaction is not closed until that replication process has happened. With Cassandra, the transaction is closed once it writes it to the first node, and then the replication happens. So what that means is it is possible that while a write is happening, there's also a read happening on one or more nodes that don't have that replicated data. So what we might have is a miss on new data, or we might have old data that is older than what has been written to another node. So that is what can happen within a very small window of time between the time a data write happens and the time that a data replication happens. And that's what we call eventual consistency. Eventually, it will be consistent, but there's a small window of time where I can read data that is either old, or I might miss a write in a given read that might be pertinent to what I'm trying to access. So that eventual consistency allows for that in a given database. For many applications, that's not a big deal. For some folks, they don't really care about that. So that's not going to make a big difference in the application. Now, if I do need the latest data to be available on the next read, that is, new data needs to be available for whatever context I'm talking about, or the updates need to be applied, then that's what we call strong consistency, and Cassandra is really not oriented around that. Now, with Cosmos DB, you can configure strong consistency. However, it's probably not recommended because Cassandra is really not designed for that. It's more designed for that eventual consistency model that allows you to have that asynchronous data replication going on so that you can scale this widely and so that you can have high concurrency with reads independent of writes that are happening on the cluster at the same time. So you don't have to manage all this locking and all this contention management in the database. And so that allows us to have that big data application going on wherein I'm not waiting on transactions to complete across nodes. So that's why we can get this scale going on. It also allows for a node to fail. If this node is to fail, then what I can do is continue to operate my cluster and not have to worry about this node being unavailable. So if this node goes down, then I can still continue to write data to other nodes and read data from other nodes, and it still gets replicated even though this one goes down. So this allows my database to have high availability in the event of a node failure. Now, this is one of the things that makes it highly available in a given data center, but also something that you can do across regions as well because of that asynchronous replication model for a given Cassandra database. It also allows me to scale this more easily. So if I needed to add another cluster node over here, I could easily do that just by simply going into Cassandra and adding a new node to this, and then all the data will start being replicated to that new node as well. So I can have that horizontal scale and add new capacity to my database as it grows. But having that eventual consistency, that masterless asynchronous replication technology built in, and all of those kinds of tools allow for wide database nodes to be applied to this database so I can continue to grow and expand horizontally without having to worry about taking my database offline to expand it or do anything. If a node fails or if I bring that back up, I can continue to operate this database, provide high concurrency, high write throughput, and all those things that I need for big data workloads. So when we talk about row storage and column storage, we're looking at two different ways of storing data, and it's basically how the data is written. So in a row store, we basically are writing data that looks like this, where the row itself is written like this sequentially. So I write the first row, then I write the second one, after that sequentially, then this one. So your data is going to be stored on the media where this row stops, this one starts over here. It's basically a single line. So if I wanted to summarize this column right here, what I need to do is read each row where I have filtered the data and basically ignore all of this data that I've read and all of this data that I read so I can summarize this column right here. And that's what you're going to be doing with things like averages or sums or these kinds of operations that typically do aggregation of data, which is going to be a very common operation in big data type workloads. So to expedite that kind of mechanism, a column store basically kind of reorients the storage so it's more oriented around a column, and so you write the column itself sequentially. So it gets written here, then this one gets written, and then this one gets written. So if I want to summarize this column, I'm going to be basically just reading all of this data sequentially and not having to ignore other kind of data that might not be pertinent to whatever summary I'm wanting to make. And so this operation right here can then be performed much quicker by simply storing the data in a column-oriented store versus a row-oriented store. So let's talk about some of the pros and cons of this. This is great for data aggregations. Basically, that means that we can read the data quickly, just like we showed. And that basically means I can summarize and aggregate data in a very quick way that would be a little bit harder to do in something that's more row oriented, such as an RDBMS. It's highly flexible in its schema, so you can do a lot of stuff with this. There's really not a lot of constraints on what you can do with the schema, although it does require that you do create a table with a schema on it when you create this. But that being said, it's easy to modify it as well. We already talked about high availability and high concurrency, because it does adopt eventual consistency, but that does make it highly available to people that are going to be reading the data. So you're going to have no single point of failure and high query performance for the aggregate type queries that we want to do on big data to get intelligence out of them. However, it does come across with some drawbacks, and that's because of the use case it's really oriented for, which is big data. It tends to be slow on joins. You can do joins in Cosmos database using Cassandra API or any Cassandra database. It's really not designed for that because it doesn't really perform well in that, because it's not enforcing foreign key relationships and doing all of that kind of stuff that you would typically expect in an RDBMS. So if you're expecting for this to be able to do joins, it's probably not a good idea. I mean, just because you can do it doesn't mean you should do it. Rather, it's best just to denormalize the data. And if you can denormalize the data, that means that you can then have a single database table that is going to have a single column with everything you need in it to perform whatever aggregation that you need. So that's kind of a best practice for column store databases like this. If you have consistency demands for this that require the latest write to be available to the next read, this doesn't support strong consistency. So that basically means that you're not going to be able to use that consistency model if you need that kind of consistency in your database. I think Cosmos will let you turn it on, but as a rule, you're not going to get any advantage from doing it. So best just to not even try to use it for that. Choose a database that does have it, like SQL Server, rather than try to make Cassandra do something it's really not designed for. And the other complaint about this is the databases tend to be airy, and that's for a lot of reasons. One, it uses tombstone deletes, which basically means that it doesn't actually delete data, it just flags it as deleted, and then it will come back and overwrite that data later on if it is deleted. Or it tends to be airy because a lot of space is needed for those column writes, or the data tends to be denormalized, so you might have a lot of data duplication and things like that. So the databases themselves can be rather large for that matter, but that also allows for a lot of this fast data aggregation and flexible schemas and other similar pros that is really what this is aimed at anyway. So if you can kind of deal with a lot of these cons and orient the data applications that you need for a wide column store towards fast aggregations, high available, high concurrency, and all those things that you really want for big data, then this is the kind of database for you. If you're just looking for something that isn't going to be oriented around big data, that you need strong consistency, you need the joins, you need to normalize data, then go with an RDBMS and not this database. Many times, if you need both, what you can do is have one for one reason and another for another, and just replicate the data between the two, which is a common practice anyway. So that's what this is aiming for: big data pros, and it's going to orient that way. Cons, it's not an RDBMS, so it's not going to work very well for that kind of purpose. So for a demo, I wanted to look at an adaptation I've done from another application that I wrote for the Cosmos SQL API, as well as for storage tables and other things. And that's where I have a syslog daemon where I'm generating data and storing it in a database. So this particular application is pretty straightforward, but I wanted to point out some of the idiosyncrasies of some of the things that you probably need to be aware of that relate to everything we just talked about and why they exist. So what I'm using here is a syslog daemon that's basically listening for stuff coming off my firewall, and then as the messages come, it kind of parses them and stores them in a Cassandra database. So this is configuring a client. This is using the standard driver that is for Node.js, but this stuff applies to any of the SDKs that you can use for Cassandra. And what I'm doing is just basically configuring this. So all of this data, all these particular pieces of information you can get from the Azure portal, but you have to be kind of aware of where they're stored, because it's important that you get this stuff right so that you don't sit there and try to figure out where in the world things are inside of your particular Cosmos instance. So the first one is going to be the contact points. Now, Cassandra, as I mentioned, is a masterless kind of configuration for a database. So you can connect to it from any number of points. So the contact points could be a list of IP addresses or a list of host names that you can put into this. And that's why we're in brackets here. But Cosmos doesn't do that. It actually does some load balancing around some of the actual DNS associated with the name that we have here. Now, I have this variable right here called Azure region, and this is needed because the local data center parameter for this particular client is needed. And Azure region is what you supply for it. So in the context of this particular one, you can say, hey, use a local data center, which tells Cassandra that you're going to be using something that's more geographically close to you. And that's kind of used to configure some of the load balancing and other types of access to the database whenever we're looking at this client configuration. So the SDK is going to do a lot of that figuring out for you. So for us with Cassandra in Cosmos DB, we can configure this to use multiple regions, and you can say my local one is East US, and that's the one it's going to attempt to use whenever it connects to this particular endpoint right here. So the port is important right here as well, because the port by default is 9042, but Cosmos DB uses 10350, so you need to specify the port in the client configuration. The key space is essentially the database, the analog. It's where you're going to be creating your tables. And so our key space is the Cass demo one right here, and that is in the Cosmos DB portal as well. So to show you where you can get all this information from, I'm going to pop open my instance of Cosmos DB right here. If I click on connection string, here is the contact point parameter, and here's the port, here's the username, and here's the password that you can use for this. And so that is those parameters that I have in my application. And here is the application name for the read locations or write locations. This is for that Azure region parameter that it gets populated in the local data center for the client configuration. So this is the basic configuration information you need for this. But once you have all that ready to go, you're ready to start using the application. So this one, it's doing something pretty basic. Again, it's just creating data in a database. So it's using a query, looks like SQL. It's using a Cassandra query language, which is very much like SQL, but don't think just because you see SQL that this is a SQL database. It's not an RDMS. It's a Y column database that does use tables. But in any case, I'm basically doing an insert statement. Here's the parameters for that. And then I call the client to execute that with the parameters, and here we get the results back. If there's an error, I write it. And this has been running for a while, just writing data. So this is that particular syslog daemon. You can see that it's writing data into the database. So again, a very straightforward application, and this is basically how you configure any of these. So let's go over the Azure portal. I'm going to talk about some of the idiosyncrasies of the Azure portal and why you might want to use a third-party tool for some of the things that the Azure portal exposes. So I have my instance of Cosmos DB pulled up right here, and this is where I can use some of the various pieces of Cosmos DB to work with the data in this, and as well as you'll get the connection information out of this as well. So the Data Explorer in this is a tool that you can use to do some basic stuff. This particular tool is kind of idiosyncratic. It doesn't allow a lot of stuff that I might want to do, like edit queries, like using just text. To edit queries, you have to use this query builder tool right here, which makes doing things in this somewhat difficult, because if a particular Cassandra database needs to filter across partitions or needs to filter data, sometimes this won't work. And you can get the query, you can get the actual SQL right here, but I can't really edit in this particular dialog box right here for this. So if I want to run queries against the data in the database, on the Azure portal, I have to open up this this little connection here using the client. This is just a shell client that you can use to do stuff inside of Cassandra. So this is basically the same CLI utility that you can install locally to do that. So if I wanted to get data, I can do a select from my Cass demo dot firewall log, firewall underscore log, like this, and then I can do where then I severity, that's the name of my fields, is greater than 9 or something like that. And I have to put and I have something in my from, select star from. And this is where it's going to tell me that I cannot do this because I need to add allow filtering to the end of this query. If I was to generate that query inside of the portal right here using this, it would still give me the same error and I can't really edit it. So I have to put allow filtering at the end of that. And now it will return the results after I execute the query. So that is kind of one of the idiosyncratic things about this that makes this UI experience here a little bit harder to use. So if you want to be able to do this, there's a myriad of third-party tools out there that allow you to do queries against a Cosmos DB instance of Cassandra. But this particular experience is fine for me for just using the CLI. If I wanted to connect to this from a local CLI, I could do that as well. But in any case, this is how you can at least view the data to kind of get an idea of what things are and do some basic administration like create tables, delete tables, and that kind of thing, and actually get into a shell experience where you can work with it at the CLI. So this does have some utility, but again, it's not the best experience. If you want that, use one of the third-party tools. And I don't really have a recommendation. I just use this most of the time if I'm working with Cassandra because it works. But in any case, if I can use this, then that's all I care about. So once you have all of this going on, you can kind of see what's going on. You can change the default consistency to your database. You can get connection information. You can do all that kind of stuff that you can with any other Cosmos API. I set mine to eventual consistency right off the gate because that is exactly what Cassandra really supports. And that's really what it's kind of intended for anyway. So I use that for my default in Cassandra. And that's the one that you will get the best performance, best throughput, and be able to handle those big data workloads, which Cassandra is kind of oriented for in the first place. So everything else is pretty much standard kind of Cosmos DB experience beyond what you can do in the connection strings and the data explorer as far as setting the consistency, backups, defaults, firewalls, endpoints, all that. That is pretty much standard. So I'm using the defaults here for the most part for a serverless install on Cosmos DB for the Cassandra API, other than just taking the default consistency and setting that to eventual consistency. So again, very kind of basic experience here, but it does work, and I recommend you use it if you can, and if not, use one of the third-party tools.
If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.